Okay, so hello people. So today we'll be solving LeetCode daily question 2642, that is design graph with the shortest path calculator. And in this, there is a direct weighted graph that consists of n nodes numbered from 0 to n minus 1. And the edges of the graph are initially represented in the given array edges, where edges I equal to from I means zeroth index represents the edge I from where to where the graph the edge is there, and what is the cost for reaching that particular node. Okay, and then what we have to do, we have to implement the graph class, where in the initially we will be given for the constructor the number of nodes and the edges, and we have to initialize that object. And in the add edge, in this, when this function will be called, we will be given an edge array from to and edge cost in the same way. And what we have to do, we have to add a node between that those particular graph between those particular edge. And in the shortest path function, we will be given two nodes, and we have to return the minimum cost from reaching node 1 to node 2. And if no path exists, then we have to simply return -1. Okay, so let's I'll not be explaining these two functions because these I mean that I'll be explaining, not be typing the pseudocode for this. These are pretty much easy. For this function, that is the finding the shortest path, I'll want to explain the Dijkstra's algorithm. So what Dijkstra's algorithm basically does is it helps us in finding the shortest path from reaching a particular node to every other node. So let's say for this graph, what we are having starting node as 0. So we can see that from 0 we can reach 2 and we can reach 1. Okay, so if we start from 0, so the reaching to the minimum cost which we can have is 3. That is if we go from this to this. Okay, so from 0 first we'll have to go to 1. In this case 1 will get covered. So for the cost for reaching 1 is 2, and then the cost for reaching 2 is 3, because okay, sorry, 2, because the cost from 2 to 1, that comes out to be 3. Okay, so this is how we can do. We can also start from, let's say, some other node. Let's say we start from 3, so there is only one, and from 0 the 3 node is unreachable. Like there is no path between 3, because we can see the edge is between 3 to 0. So let's say if we start from 3, then what we can do, we can from 3 we have to go to 0. Let's say in the question we have asked to find the shortest path between 3 to 2. Okay, so what I'm considering the case is 3 comma 2. Okay, so this is the case. We have to find a shortest path between from 3 to 2. So we start from 0 3, then where we can go, we can go to 0. We go to 0 with the cost of 3. Then from 0 we can again go to 1, or we can go to 2. If I go to 2, then the total cost will be because the reaching cost from reaching 0 to 2 is 5. So this cost to me 8. This cost to be 8. Okay, but what I do, if I go from here, then I go, the cost of reaching 1 is 2. So here the total cost will becoming 6. Sorry, 5. Just a second. Yeah, so the total cost here is 5. And then what I can do, I can reach the node 2 with the cost of 1 only, and this total cost is 6. So 6 is definitely better than 8. So what we'll be doing, we'll be following this path, 3012. Okay, so this is what Dijkstra's algorithm help us in doing. Okay, so first let me write the pseudocode for the Dijkstra's algorithm. Firstly, what we'll be doing, we'll be having an array. Okay, sorry. Yeah. Let me just. Uh, okay. So firstly, what we'll be doing, I'll be having an n will be equal to the current length of the adjacency list, j list dot size. Okay, the total number of n, and then what we'll be doing, I'll be initializing a priority queue, which will be basically a min heap of a list and list of integer. And what I'll be doing, I'll be sorting this priority queue. Let's call it min heap only, min heap, and I'll be sorting this on the basis of the distance, that is list comparator uh, comparator dot comparing int list, and list will be the variable list dot get 0. Zeroth will be the basically the distance in the the list, at the 0th index the distance will be present for reaching that particular node. Okay, so what I'll be doing then, I'll be initializing a variable, an array, sorry, of for that reaching that particular node, that is of size n. So let's call it cost, only cost of size n. And then what I'll be doing, I'll be saying at first, like let's say I'll be filling cost array with the maximum value, because there is a chance that because we have to find the shortest path also, then that's why we are also filling the maximum value for reaching that particular node. Or there could be a chance that there is no possible way of reaching that particular node, so you can, so in that case we have to return -1. Okay, so and also we can see in this case, like let's say the cost for reaching if we start from 3, so the cost for reaching 3 is 0 only. So what I'll be doing, I'll be setting the cost for reaching node 1, that will be equal to 0. And then what I'll be doing, I'll be offering min heap dot offer arrays dot as list 0, because the distance will be 0, and comma node 1. Okay, because for reaching the node 1 the distance will be 0, and we are starting from node 1 only, because the question will be given that from where to where we have to find the shortest distance. Okay, so then a while loop, while not min heap dot is empty. Okay, so what I'll be doing, I'll be using a current variable that will be equal to min heap dot pool, and in that let's have a variable, let's say current cost for reaching that particular node, that will be equal to current dot get 0, and current node meaning which at which node I am present, that will be equal to current dot get 1. Okay, so for what I'll be doing, that if current cost is greater than cost for reaching that particular node, current, that is that current node, so what I'll be doing, I'll be just simply continue. Or if otherwise the other ways, that if my current node is equal to the, sorry for that, node 2, that is the node which we have to reach, so what I'll be doing, I'll be returning current costs in that case. Okay, or otherwise what I'll be doing, I'll be using a for loop. Let's say neighbor, or yeah, node, let's say in adjacency list dot get the nodes through which the current node and the nodes that are connected to that particular node, for node in adjacency list. So what I'll be doing, I'll be using node okay, so let's call it neighbor, will be equal to adjacency list dot get key, sorry, dot get key, and the cost for reaching that particular neighbor will be equal to neighbor cost, neighbor cost will be equal to node dot uh, sorry, here it should be node dot get key, yeah, node dot get value. Okay, so let me just make it small and add a new text box. So reaching the cost for reaching that particular neighbor, and then what I'll be doing, that my new cost, that will be my current cost, will be equal to neighbor cost for reaching that particular neighbor cost plus my current cost. Okay, and then what I'll be checking that if my new cost is less than cost for reaching that particular uh, neighbor, then what I'll be doing, I'll be setting that cost at that particular neighbor will be equal to my new cost. Okay, so and what else I'll be, okay, just okay, yeah. So and then after this, what I'll be doing, I'll be offering min heap dot offer arrays dot as list, and then new cost comma neighbor neighbor. Okay, and if I'm still not able to find the answer after all these loops, what I'll be doing, I'll be just simply returning -1, that there exists no path between the particular nodes. Okay, so this is how what I'll be approaching the question. Now let's start solving it and the coding window. uh, yeah, so firstly let me just zoom in. Yeah, so here what I'll be doing, I'll be using a list of pair or pair integer comma integer. So this is the standard way how we can declare a adjacency list when in the case we are given a directed graph, or and also a directed weighted graph, or simply if we are even given a weighted graph. So let's call it graph, and then now let's initialize that graph will be equal to new array list. And firstly I'll be adding empty array list, empty array list. So for and I equal to 0, I equal to 0, I less than n, then I plus plus. What I'll be doing, I'll be just adding graph dot add new array list. Okay, so I've added empty array list to the graph list, and then what I'll be doing, I'll be adding the edges. So for that I'll be using a for each loop for int edge in edges. So what I'll be doing, graph dot get edge 0, meaning from that particular node, graph dot get edge 0 dot add new pair of edge 1 comma edge 2. So this is how we have just created the graph, and in the case when we have to call the add edge function, we'll be just simply doing uh, this command only. So let me just copy and paste this only. Graph dot get edge 0 dot add new pair edge 1 edge 2. Okay, so now let's write the code for shortest path algorithm. So let's have a variable, let's say n, that will be equal to graph dot size, meaning the particular nodes that are present in the graph currently. And then what I'll be doing, I'll be using a var instead of a particular variable. Let's call it min heap, that will be equal to new priority queue, which will be I'll be using a comparator here, comparator dot comparing int in list, and this is a lambda function. And what this will be doing, this will be sorting the min heap on the basis of the distance between the particular nodes. List dot get 0. Okay, so and after this, what I'll be doing, I'll be initializing a cost array, cost that will be equal to the size of the current edges that are present, and then arrays dot fill cost comma in into teacher dot max underscore value. uh, okay, so and then what I'll be setting that cost for reaching the node 1, that will be initially 0. And then what I'll be doing, min heap dot offer arrays dot as list 0 comma node 1. Okay, so then what I'll be doing, that while my min heap is not empty, I'll be using a var current that will be equal to min heap dot poll. And here what I'll be doing, I'll be having a int current cost that will be equal to current dot get 0, and my current node, that where the node where I am particularly at, current dot get 1. Okay, and then what I'll be doing, that if my current cost is greater than the cost for reaching that particular node, cost at that current node, what I'll be doing, I'll be just simply continuing, because we don't have to find the path that, and the case in which we are, let's say, in this only, that we are having in the initially distance array will be, in the case of 3 to 2, it will be like when we start from 3, so 0. Okay, no, sorry, let me just create a new and just copy that particular image. Okay, so just a second. I don't know why it's taking a lot of time. Let me just start explaining my then that firstly, but okay, I can't even draw by the time the image is not getting uploaded. Mm, okay, so nothing is happening. Let me just open a new the whiteboard again. Just a second. Yeah, now what I was saying, that if we, let's say we are given that we need to reach from 3 to 2, so initially what this algorithm will basically do, let me just firstly form an array. So this is how my array will be at the starting with max value. I'm just writing m for max. It is of size 4. Okay, so this is how my array will be firstly looking at in the first iteration. Then what I'll be doing, okay, let me just increase its size. Yeah, so what I'll be doing, as we have to reach from 3 to 2, so I'll be just setting the cost for reaching 3 node as 0, and in the min heap, uh, what I'll be doing, I'll be adding 0 comma 3, and from 3 and I'll be just popping it off. So and the array I'll be setting 0, and then from where I can reach 0 only. Okay, so yeah, 0 comma 3 will be added. Then what I can do, I can set this m, because as there is only one node where we can reach, so I'll be setting this to be 3, and from 0 comma 3, what I'll be doing, I'll be adding the rest of the two nodes from 0 to which 0 can reach, that are basically 0 1 comma okay, sorry, 2 comma 1, because we are adding in the here also, I guess I added in the opposite way. We are added 3 comma 0 instead. Okay, because firstly we'll be adding the distance, and then we'll be adding the node. Okay, so reaching 2, and the other node pair which we'll have to add is 5 comma 2. So as it is our main heap, so firstly this will be getting popped off, so that is 2 1, and then as I can see that the cost from reaching 3, and then I'm currently at 3. Okay, this is the cost, and then I'm currently at 0. Okay, so from reaching 0 to 1 I'll be costing 2. Okay, so I'll be costing 2, so the my current cost still stands was 5. So and after 1 I can see that I can reach node 2. So what I'll be doing, I'll be just adding this pair, that is 1 comma 2 into the min heap, 1 comma 2, and then as it is a min heap, so okay, and here at this array my value will become 5, because the cost from reaching 3 to 1 is 5. And then what I'll be doing, I'll be just, as it is a min heap, so this will get popped off first, 1 comma 2. So my current cost is 5, and then I can see that I'll be reaching node 2 if I add 1 to the current cost. So as 6 is less than the maximum value, so I'll be adding 6 here. Okay, so as the while loop will run while the priority is not empty, so now 5 comma 2 will get popped off. So what I can do, that my from 0 only, that my current cost by now is 3, and if I do 5 here, so my current cost will become 8, and 8 is obviously more than 6, so we will not be cheating anything. So this is how the algorithm will work. Now let's get back to the algorithm. That if my current cost is greater than the cost of reaching that particular current node, okay, so yeah, so and then I'll be checking that if my current node is equal to the node 2, meaning my target node, so I'll be just returning current cost. Okay, and then what I'll be doing, I'll be using a for loop again, for var neighbor in graph.get graph.get current node, and here the neighbor node will be equal to graph, oh sorry, neighbor dot get key, and my value will be equal to int neighbor cost will be equal to neighbor dot get value. Okay, and then my new cost will be int new cost will be equal to neighbor cost, sorry, neighbor cost plus current cost. Okay, and then after this for loop, okay, in this for loop only, that if my new cost is less than the cost for reaching that particular node, that is my neighbor node, neighbor node, I'll be setting my cost for reaching that particular neighbor node cost, neighbor node will be equal to my new cost. Okay, so yeah, so let me just put this in the parentheses. Yeah, and then what I'll be doing, I'll be min heap dot offer arrays dot as list new cost comma neighbor node. And if we still don't find the answer, we'll be returning -1, because this means that there is no possible option for reaching that particular node. So now let's run it. it says can't find symbol current dot get list. Okay, so there's an error in this. Uh, comparator not comparing int list implies list not get 0. Okay. Oh, okay. Here I didn't change the parameter that the priority queue will be of type list of integer. Yeah. Okay, so now let's submit, run it again. Okay, it still says compiler error. Okay, main heap there's okay, yeah. Here it should be capital. Sorry. Now let's run it. And it gets accepted. Now let's submit it. And yeah, and it works completely fine. Okay, so this was it for today. Thank you for watching.